Welcome to the WorldTech IT Podcast, where enterprise technology meets real-world strategy.
Hey, everybody. Welcome to the WorldTech IT Podcast. My name is Eric Munn, the VP of Marketing at WorldTech IT, joined by...
Josh Brooks, Chief Solution Architect here at WorldTech IT.
Ernie Martinez, Practice Manager for Red Hat and open source projects.
Robert Davila, Practice Manager for Networking and Security.
And Jacques Barbeau, Professional Services Practice Lead here at WorldTech IT.
And today I am joined by a group that has just seen the very frontier of technology at GTC this last week. But I got to start by asking the crowd here, what is GTC? Why should we care about it? Why did you guys even go out there? Josh, explain yourself.
Yeah, I'd say the biggest reason we went out to GTC is every year you just see what's on the cutting edge of AI, whether that's like agentic coding, world models, simulating climate, physical AI, whether that's self-driving cars or manufacturing robots, applications in healthcare, finance, the list goes on, right? There's not a vertical that NVIDIA is not touching right now.
So it started as NVIDIA's big conference, and recently with the big AI boom, it's gotten even more popular. Is that a good way to sum it up?
Yeah, I mean, it started as a graphics conference, right? Back when NVIDIA was just focused on gaming.
Exactly.
And with this AI, revolution, industrial revolution 2.0, whatever you want to call it, it's morphed into all things artificial intelligence.
Very cool. Well, Josh, we know that you've been there before. Anyone else attended in the past, in a previous iteration last year, anything like that?
No, it was my first time.
All right. So then, Ernie, what did you think first time? What were your impressions?
Well, first I was blown away because last time I even logged in or saw any streaming, it was mostly focused around gaming, and so when I looked at chipsets and things that they were doing, most of my interest in NVIDIA has always been around gaming performance, frames per second for my first person shooters and my next gaming rig. That's typically where I've always had been a focus with in NVIDIA, and coming from a background in ASIC design and how touching quarter micron or 250 nanometer, depending on how you want to date yourself. Seeing what they are doing now, I was just blown away by what they are fabricating and what they are producing. I mean, it made me feel ancient compared to my quarter micron TSMC days.
So there's been a big evolution there. I did want to ask you, though, do they maintain a bit of that old gaming conference spirit, or has it totally been transformed? What did you think, Ernie?
Oh, absolutely. If you look at what they were live streaming, just the AI enablement on gaming characters, the shaders, and what they were doing was just mind blowing to bring realism to gaming. And my mind goes from gaming to virtual reality to augmented reality, and just the things that you can do with the new AI chipsets. So absolutely, they're still true to their core. But now with their NVLink and the like for their systems that they've built and the integrated systems, the integrated chipsets, it's just unfathomable how much processing power NVIDIA has created in the AI compute space.
That's awesome. Yeah. Robert, what were your thoughts?
It's interesting how gaming is kind of foundational across all these groups, right? I mean, you go talk to the surgeons that are leveraging robotics and the guys that are masters at the craft. They're young and they'll tell you flat out, I was a big gamer, and it's not much different than here today, right? And true to that form, I feel like at the conference I maybe saw a little bit about gaming, but I was just amazed to see the different industries and kind of how they're applying the technology. I went from talk to group to just, and every one of them was just kind of mind blowing in terms of where they've grown. So it was definitely a eye-opening experience across different industries for me.
Love it. And last but not least, Jacques, your impressions. What did you think?
Well, the impressions were that I've never been in a group that large. Like it was a massive wall of people.
How many people? What's your estimate here? I mean,
they were saying close to 40,000, 39.7 or something. Like it was a huge number of people. Like I'm used to going to F5. I remember going to Cisco Live back in the day. It never got that big. This thing was
really
things were just massive.
The keynote had the SAP Center basically sold out. Every seat was filled.
Yeah.
Oh my
yeah.
God.
Like the hockey arena, man. Like it was crazy. I showed pictures to my wife when I got back, and she couldn't believe just how stuffed it was for this guy's. They're listening to a CEO run a marketing pitch. They crammed a stadium full. Yeah, they did, and enjoyed every minute of it. So yeah, it was just fabulous to see all of that, and then to combine that with the open exhibits, the talks, all the massive amounts of robotics that were to be found all over the floor and outside. Yeah, it's just phenomenal. It blew me away.
That's awesome. It sounds like it was definitely the hot ticket. Glad you guys were all able to go out there. Now, you're each subject matter experts in your own specialties, right? And I'm curious, what each of you saw that really raised your intent, that you thought, okay, this is going to change the way that we're going to work on these technologies that we specialize here at WorldTech IT. Any big ones that come to mind immediately here, Josh?
Yeah, I mean, there was kind of two. One of them's not directly relevant to what we do, so I'll start with what is, and that was a lot of the agentic coding and what NVIDIA has done, even with things like taking OpenClaw and wrapping their own stack around it and guardrails and such. But not just that, what they're doing with like the folks at LangChain and what they're doing with their own internal models and giving you an entire stack to go build, not just for inference, but to build agents that can do things like RAG or fully automated end-to-end workflows or automation inside of a factory. Like they're delivering entire toolkits, not just infrastructure and hardware, right? They've fundamentally become a more integrated company. So I think you're going to see more from them where you can literally just buy the whole kit and caboodle from the hardware to the software stack, and you just bring your data and bring your business process, and you'll be able to crank out agents. The other thing that was really not so much eye-opening, because I saw it last year, it was just an evolution of that, is what they're doing to enable manufacturing, where you don't have this constraint of human labor supply, either for very dangerous jobs or very repetitive jobs where humans just aren't happy doing that, for one. And then for two, there are a lot of high risk jobs. So I think you're going to see a lot of changes from like a manufacturing and just industrial automation perspective as well.
Got the software hardware split. And I want to circle back to the OpenClaw at all a little bit later in the pod. But anyone else in your field, what are you seeing here specifically?
Sure. I think for me, the SuperPOD designs, I mean, getting hands-on in terms of building and really working in the lab.
Okay, what is a SuperPOD? You have to break it down for us who weren't able to attend. What does that mean?
So a SuperPOD is a large deployment of GPUs that you can leverage for AI workflow, right? And it integrates into a traditional leaf-spine network. But the interesting thing is how it connects with things like NVLink on the back end to do just high-scale AI processing. Building that infrastructure, being able to kind of interact and play with it, and think holistically about the scalability in terms of it was it's probably one of the best classes I've done in a long time in terms of that side of the house, and seeing how it functions and where it's going. And it was interesting because they had one kind of design model that we did in the class, which was before the conference, and then of course Jensen gets on stage and says, "Hey, here's our next gen version of that. That's double the capacity," which is a little mind blowing when you start looking at it. So I think that was a big thing there for me, and kind of seeing how it all stitches together from that perspective, and getting hands in the architecture.
So is your takeaway there, I'm just curious, do you think that there's going to be more networking, or do you have to be smarter with the networking you have from this Arista, from the spine architecture perspective?
Arista plays really well into it in terms of spine leaf on the kind of traditional networking side. The designs are very much designed for AI enablement for large scale hyperscalers. But not just that. I mean, you can definitely build these type of environments in the enterprise if you have the cost structure that warrants it, obviously, because these are very expensive infrastructures to build for an organization. But
I'm ready for y'all to give me my SuperPOD. I'm sold. Let's get it going.
Yeah, me too. But on that perspective, having Arista just did their XPO announcement, which is their high-end optics that are liquid cooled, and those cabinets play very well and very much mirror what you would see in an NVIDIA stack in terms of what they look like. So seeing them kind of lockstep in terms of, hey, where the technology is going and how does vendors like Arista play into that market was good to see in terms of there is kind of a unified approach moving forward. But yeah, very, very much. I mean, it was great, really, just kind of seeing all that technology together, working and functioning, and how it works.
Awesome. Anyone else? What are we thinking here, guys?
So for me, it was. Oh, go ahead, Jock.
No, it's okay, Ernie. Go ahead.
I was thinking, when they looked at these high density GPUs, and when you talk about the enterprise enablement and their go-to market strategy for these CSPs, these providers, so AI gigafactories, the part of the backbone of what they want to do is offer this GPU as a service and AI as a service, and that backplane helping control some of this is Kubernetes, and leveraging Kubernetes namespace is where GPU allocations. So it's just where the industry is going, the importance of understanding Kubernetes, especially if you're building out your own internal AI factory or consuming it as a service. It's Kubernetes. We see the partnerships with Red Hat OpenShift. We see the partnerships across the stack in building this AI ecosystem, whether you're using NCCL, NVLink, RDMA. There's a lot of technologies. And the fact that we are now to the point of requiring or needing liquid-cooled optics, mind-blowing.
Wow. I mean, did you get to see what that looked like? Was that on the floor, some liquid cooled optics?
Oh, yeah.
Yep. Very cool.
They had it all out for show.
Yeah. I mean, everything was liquid cooled, right? And some of those cabinets were 300 plus megawatts to the cabinet. Like, you can't do that kind of energy density without liquid cooling.
Next time you guys complain about plumbing, I'm just going to remind you the future's coming for you. Okay. So, tying all these things together, the metaphors are getting more mixed as time goes on. Jock, what were you saying?
Well, as a network guy, for the last 30 years, the sheer numbers as far as throughput and interconnections inside of these cabinets made it feel like we're like on the pedal, like the bicycle track as far as the network's concerned. And then once you get inside the cabinet, now it's like just mind-blowing numbers as far as throughput, right? We're talking like 3.6 gigabytes per second, terabytes per second. Sorry, that's just how crazy it is. Like 8 times 1,000. Compared to what we can do our best on a leaf spine network, right? It's insane. Just the sheer amount of traffic that's going through there, and it's no wonder that it's running so much heat to make it all happen. Jensen was on stage, like holding up the interconnect in his hands, and it was like this just massive bar of all these tight interconnects, and it holds like I think it was like 3,800 connections all in one go, and you just kind of slam it into the back of the servers and like done, right? Because they're all interconnected with each other and the CPUs. It's just insane. Like, it's mind blowing. Made me feel a little inadequate from a network standpoint.
Well, there'll be more to follow up on there. I'm curious too. Were you guys able to see anything specifically around F5, since that's usually our bread and butter when it comes to these things?
Well, we've discovered where F5 really sits in the stack here, and it's really being pushed just like the networking further and further to the left. It's going to be able to fit in, especially with Bink, right? In being able to, as close to the workloads as it can be, but like once you're past that point, right, and you're into that fabric, all that decision making is already happening with Dynamo and everything under the covers. So it's there at the edge. It's going to do a fantastic job being able to steer traffic into Dynamo. I'm sure it'll interconnect with all of that. But like NVIDIA has it just owned once you get into that fabric, and we just have to kind of move along with that.
Yeah, I mean, and it's part of the secret to their success, right? If you look at some of the stuff that came out at that keynote, as far as how far they've been able to push scale, tokens per second or tokens per watt or whatever metric you want to use, especially the more premium tokens, right? Think of like Claude Opus. as far as they've been able to push that, the only way you can do that is by integrating all these things together. Like if they didn't build that crazy networking that exists in the cabinet, they wouldn't be able to scale across all of these GPUs. Because the secret nobody talks about is like they're at the scale of silicon per GPU. It's a full reticle die. You cannot make a die any bigger than full reticle. So the only way for them to continue scaling is to scale out with more GPUs per cabinet. And so those high-speed interconnects become critical to scale out across that many GPUs in a cluster.
Yeah, and that's where those kinds of edge devices will really come in, right? And that's where Robert and I still have a living to do with connecting these cabinets together, from the network standpoint.
So then from that network standpoint, from even the data center standpoint, what are some other things that people should be looking out for, thinking about as for what you've seen on the GTC floor here? You've mentioned a ton of different things here, but anything else to shout out here, guys?
800 VA guys, right? Like there's so much power that's needed into these things. Everything's moving to 800 volts. It's crazy. All the cooling, they had some wicked displays about all the cooling and all of that to go along with it. Like when you think about just how much juice you're pumping in order to get these high performance, tokens going, you got to pump the heat out too.
Yeah, I mean, they had some cooling displays there that it was like a couple of these is like 1.6 megawatts of cooling.
Like it's like,
wow.
Yeah.
Good to know. Good to know. Okay, well, let's pivot off the hardware for a second. The big buzzwords I was seeing around there is it seems like everything is going agentic, and it seems like OpenClaw dominated a lot of the conversations despite being new on the horizon. So what did you guys think? Is that a good assessment here? What else did you see on the software side?
I think agentic was an important topic of discussion because if you think about the root word of that agency, right, it's actually giving AI the ability to do things. I saw a lot that wasn't around OpenClaw, that was about enterprise applications, whether you're talking about using LangChain or some of the derivatives of that, like LangFlow, which is a DataStax product. It's basically a GUIfied version of LangChain, or N8N or Crew AI, right? There are all these other wrappers for building agents that aren't OpenClaw. So there was a ton around agents and how you actually get AI to do things, whether those are like business process agents or real physical agents that are running hardware, i.e. robotics. And then I think the OpenClaw bit was just, that's something a lot of these engineers can get their head around, right? It's like, oh, I can go deploy this on a Mac Mini at home and watch it do all this crazy magic. And then of course, they have their wrappers for all of that. If you're running with an NVIDIA graphics card and a workstation, or if you're running on like a DGX Spark.
I mean, being from a security background, I figured that there would be more hesitancy, but just the fact that you're able to iterate on such a thing so quickly, is that what's really expanding the adoption behind it? Or was there a lot of talk about security? You guys tell me.
There was a lot of talk about security. I mean, that was one of NVIDIA's biggest concerns with the OpenClaw stuff, and that's why they created OpenShell and announced that during the keynote as a set of controls that can be put in front of OpenClaw. Like once you have an agentic AI running around hooked into everything that you want to throw it at, able to do and act on its own under your guys, you obviously need some guardrails to be able to do that safely. Otherwise, chaos ensues, right? So it looks like they've really thought at least this first generation of controls through quite well. OpenShell, I've been looking at it since we heard about it. It looks very interesting. It definitely makes it a little bit more approachable in the enterprise. But like they're not the only thing on the spectrum. As Josh mentioned, there's a whole set of tool chains that are trying to do very much the same thing. We're at an interesting place. Everything's moving so fast; it's really hard to keep up and do it safely.
Yeah, and I think on the security side, it's enabling it there just as well. I mean, we spent a lot of time talking with people in various industries, kind of how they're leveraging technology, and that included cybersecurity and security folks as well, in terms of how they're kind of taking advantage of the opportunity to really kind of do inference or leverage AI workflows in their kind of day-to-day job as well, right? Now, obviously, there's always some guardrails that you need to put in place in terms of security, but I think that those things are, you have the ability to leverage kind of what's being built as part of that for you. And I mean, you know, I just saw a recent project where they were running existing code through Claude Code to look for security problems that they probably didn't find before, right? So I thought that was kind of interesting, the one that came up recently on Hacker News, I believe. So you know, it's definitely technology is coming. There's always going to be hiccups right now on the security side, but I think that you know, a lot of eyes are looking at it in terms of that piece. You know, for organizations and that are looking to deploy it, you know, whether in the enterprise or in you know, manufacturing in those verticals, I think it's taking a real critical eye in terms of you know, how can I deploy this in kind of in a safe manner for organization.
Part of it's just that the gains are so much to be had, right? That people are willing to maybe bend things or shove it in a corner over there so that it can be a little safer in the meantime until those controls come across, because the gains that can be had from having the access to tools like this really far outweigh some of the risks, right? There's always a balancing act here, but man, the things that can be done with this definitely have people excited.
Yeah, and you said it, Jacques, it's a balancing act, because, you know, as we know, Jensen's the token king, and he wants everyone to consume the tokens.
Token king.
Oh, yes.
So he was announced the token king at GTC, and he wants everyone to burn tokens. And when you have this, you know, agentic self-recursion, I mean, it's so funny how a recursion problem from a basic computer science, you know, problem can lead to the consumption of, you know, unlimited tokens if you're not careful, or you're running out or burning your quota. That's allotted, you know, over the course of a day. I know that I ran into that when I was testing at the house, is using OpenClaw, just constant searching, you know, against some of my feeds, my news feeds, and it was just this never endless loop of searching and continuous research. And next thing you know, I've hit my quota. It says you can't consume anymore until after midnight or 2 a.m. or whatever the service said.
Token king at work, it sounds like to me.
Exactly. He's all over it. The more you spend, right?
You know, and the other thing about, you know, the agentic systems, and there was a talk, and it was really interesting because they gave the sub agents basically their own individual personalities, so that way when you're debugging or we're trying to know where the agent is stuck or needs help, or who's speaking to whom, you know, they gave the QA agent a British butler type of personality, maybe basically overseeing the processes, right? The security team was more of a militant, you know, personality, speaking to you in such a manner, so that way they could see in the logs who was checking whom, while the agents are communicating with each other. So it was really interesting to see how they built these personalities within the agents, so that way they could, one, debug and track the conversations being had by these agents.
Very cool. Gives them their own signature as well. Well, let me ask you guys this. If someone watching this was interested in starting to use more agentic AI at their company, what are some ways that WorldTech IT could help them with that? I'm thinking about services and potentially even Network Engine as their product here. You guys tell me.
Yeah, I mean, it's definitely around appropriate application and wrapping, you know, those security guardrails around it. I'm not sure if OpenClaw is, I mean, it could, right? Especially now that guy's working for OpenAI, is going to become some sort of crazy enterprise thing. I think for right now, it's an awesome proof of concept and like a powerful tool for power users. I think what's going to probably be more prevalent in the enterprise is things like LangChain, where you build a single purpose agent and you have a whole bunch of these single purpose agents that are doing their single purpose task, because that lends itself well to using much smaller models that have a much lower cost per token, as opposed to sending everything to these expensive frontier models, right? Don't get me wrong, you can do a lot of damage with Claude, but Opus also gets expensive.
Yeah.
Yeah. Any other ways we can help folks that are kind of looking to get into this, even though this is a burgeoning new technology?
Yeah, well, I think a natural kind of bridge for a lot of organizations is leveraging AI feature sets that are already in their product lines that they're leveraging today. You know, there's quite a lot of it in Arista in terms of when you look at Cloud Vision, On the Palo Alto side, there is definitely AI integrations for a lot of things. If you're looking at like Strata Cloud Manager as an example, there's a Strata Copilot that exists in there, right? So I think starting there kind of gives you that initial phase of really kind of understanding, hey, how can I use this tools within at least a safer, controlled kind of manner. It gets interesting when you start looking at PI and PHI, when you want to start doing runs against your internal workloads. And, that's where I feel like, consultative approach, where we can definitely help in terms of really kind of helping identify how much exposure do you want to give that AI to your internal data, and leveraging it, and what kind of strategies are there, right? I mean, we have, our projects that we've been working on as well, and our internal integrations of really kind of helping companies figure out what that strategy is that makes sense for them.
Yeah, and then there's also different approaches depending on what models are you running, what infrastructure are you leveraging. Are you doing stuff in the cloud? Are you doing it on-prem? Are you doing it with AMD GPUs or NVIDIA GPUs? Did you buy into like the whole NVIDIA stack, or did you just buy like some HGXs, which is just a server with a couple of GPUs in it? Like, there's so many different ways depending on what your workload is and what you have access to put this infrastructure together. And I think that's really where we can help you with that consultative approach, because it's going to be very different if you bought the whole kit and caboodle from NVIDIA, as opposed to if you're doing more of like open standards infrastructure, where maybe you're doing a bunch of Arista switching and you've got some AMD GPUs, or again, you're doing a bunch of Arista switching, right? All Ethernet, no InfiniBand, and you're using HGXs. That's going to be a bit different to operationalize and bootstrap everything, as opposed to, hey, I bought all the NVIDIA goodies. And there's various flavors of the NVIDIA goodies too, right? Not everybody's going to get a SuperPOD or DSX, right? The entire data center in a box, basically. Some folks may just get some HGXs and maybe a handful of InfiniBand switches, right? And so there's sliding scales to this, and you set it up a little bit differently based on what you're trying to accomplish, as well as training versus inference, right? Depending on the actual AI workload, there's nuances there as well.
And we see this coming out of IBM. We saw HP, Dell, providing not just based on NVIDIA chipsets, but creating their own solution. So that way, maybe you don't need the entire cabinet from NVIDIA, but maybe you want to do some AI, dabbling and testing in AI within your data center. And so when you look at those stacks and how they're built and how to use Kubernetes and namespaces and that integration to basically allocate GPU utilization per namespace, that's where we come in, being Kubernetes experts and being able to help you manage and configure your OpenShift.
Yeah, part of the beauty of this whole thing is that with all the strong engineering that NVIDIA is putting into all of these products, they're sharing how it's done with a lot of open libraries, open models, models that you can take and run on-prem on other hardware. And depending on how much of their stack you want to use, you don't necessarily have to go down a particular line of inquiry. I mean, NVIDIA can only pump out so much stuff, and not everyone's made of of gold, right? Which is, let's face it, that's what you're going to need to get on your hands on some of this stuff. The open source kind of ecosystem that they're forming around all this stuff means that there are other options, and they won't be as fast, they won't be as crazy, the models won't be as large, but they may be better suited for your actual needs. And being able to take in that whole ecosystem and be pliant with it and being able to create cool stuff is something that we can definitely add with.
Very cool. Very cool. Well, we talked a little bit about some of the buzzy topics here at GTC. We talked a little bit about some of the cool things we saw on the floor. What about the sessions? Anything to call out there, guys?
I think one of the biggest things that we saw, and this was, especially near and dear to my heart when it comes to like network engine and making hardware, was what they've done with ARM CPUs in the data center. Like, ignoring GPUs and everything else, like what they did with those ARM CPUs and using NVLink to connect every core to every other core in a full high-speed mesh like they do with the GPUs. It's just insane, the performance they squeezed out of those things. And it's a single SKU that basically beats everybody in single-threaded performance or multi-threaded performance. Like, it doesn't matter.
Well, and they're pushing it to other manufacturers, right? They want people to use this chip. So they want Asus to use it. They want Dell to use it. They want IBM to use it, right?
They want Supermicro to use it, right? They want
everybody
people like us to use it. The CSPs to use it. Well, the CSPs are already using it. But yeah, they want everybody to use it. And it's, the only limiting factor for us from like the network engine perspective is there's very few NVAs that fully run on ARM, but that's rapidly changing.
Yep.
So I think just across the board, you're going to start seeing more and more of ARM eating the CPU market. I mean, it's already done it with laptops and phones. I mean, I'm on a Mac right now, right? That's got nothing but ARM cores. And I think you're going to see more of that in the data center, and especially like everything in AI. NVIDIA's, their HGX systems, they still have good old x86 CPUs in them, but all of their DGX stuff, the SuperPODs, the whole data center in a box, it's all ARM CPUs, right? There's no x86 in there.
Which is fantastic. I mean, as far as efficiency, even just raw efficiency, the ARM just beats the pants off of anything x86. When you're talking about pouring, literal power stations worth of power into a single rack, that efficiency becomes important as well, right? So.
Right. And I mean, it's the beauty of a reduced instruction set as opposed to x86, which is really bloated over the years. You have all the SSE extensions, and then you have all the 64-bit and transitory extensions. And
all that back compatibility is a big thing to carry with you.
Right. Whereas ARM has a much reduced instruction set that really gets down to modern brass tacks, and it just screams, and it shows, and not just the performance, but in the power that it uses.
Yeah.
I like it. All right, guys. Well, if I'm watching this, what would be the one big thing you want to flag for me that you took away from GTC? Just if we're leaving with something, what's the big message you want to give to people from your time at GTC last week?
I think, and this is just my perspective, and this is almost universal, right? I think we're just going to see a lot more of agentic systems in our lives. I mean, I live it every day driving a Tesla, right? The thing drives me around. Those are a bunch of AI agents running on that computer in the car, figuring things out. We're going to see that, we already see some of that in our phones, but we're going to see more of it in our phones and our email and our office applications and our productivity tools. Like, if you're not interfacing with AI, you're going to be doing something very wrong, right? So a lot of these slides in these sessions, we're talking about it's the second industrial revolution. And if you think about it, for a lot of tasks, it really is. It's mechanization and automation just of knowledge work. And I don't think anybody here likes preparing long, drawn out documents. And that's something it's already great at doing today, right? So you're going to see task change and the tools you use change. And I think work's going to get a lot more exciting because you're going to get to focus more on ideation and using that dynamic intelligence that differentiates us from AI, and let AI leverage its static, repeatable, non-feeling intelligence to do a lot of the grunt work.
My perspective is, software enablement. If you're not using agents to be your QC or your security observability stack from the CI/CD pipelines, you're missing out on your speed and go to market. It's much faster to run these AI agents to do your code check, code analysis, and be part of your QC team and security team. And it does it much faster than any human can, providing some oversight. So that's where I see it. It's like, if you're not enabling your team to use AI, you're falling behind. And so the token king needs his tokens, and you will see an immense return on investment by enabling your engineers and your staff to utilize AI for development.
Yeah, I mean, to springboard off of that, security teams have been counting on machine learning models to help them swim through massive amounts of log data and of telemetry for ages. The models are getting better and better at that, and the analysts now look at what's actually interesting instead of just drowning in this sea of information. And it's those kinds of heavy lifting tasks that this will be fantastic for. It'll free up the smart people, the people that can think, to focus on what's actually needed and let all the grunt work happen with the grunts, right? And again, feed that token king it's his dollars straight in.
Yeah. You know what was interesting about Jensen? Right after his speech, he went down to the vendor village area, and I was walking in, and First of all, I had no idea he was there, right? So you walk in, and there's this pile of people, and I'm like, "What is this? A K-pop concert?" Like, phones are hanging over, and everybody's kind of looking, and I'm like, "Oh, he's sitting over by the Dell guys," is what he was doing, and it was kind of funny because I was like, "Oh, is there a robot? Is there something going on there?" And, no, it's just Jensen. But I think that the interesting thing about all of this stuff, and and especially in my experience, is that I think that it creates a level of efficiency for you as a person in terms of how you interact with your workload, things you have to do. I mean, it really kind of makes yourself, you have your own virtualized company. You think of it that way. So if you start using agents correctly, it makes you just insanely more proficient and ability to be able to kind of deliver on items. And I think that that's going to raise the bar, right? All of a sudden, you're not going to have the guys that try to sit back and just kind of sit in the middle tier. They won't. There's just not going to be a role for them over time, especially in kind of our careers, right? I don't know about other industries, but definitely technology. I think that people are taking advantage of it are 4, 5, 6x, 7x able to have in terms of their output versus kind of where they were maybe a few years ago. So that was probably the biggest realization for me. I mean, you see large scale companies that weren't large scale, right? They're new to the kind of newly established organizations, very lean, and it's because their teams are leveraging AI to kind of offset having a large scale staff.
Yeah, and to lean into what Robert said, as somebody who uses a lot of Claude code, you really have to change your mindset. Our CEO Austin always says it's the age of the architect. And almost really is, if you can orchestrate that team and keep the ideas going and keep them in line and run it like a virtual company, you can get a lot back out of it in a short amount of time. Now, those tokens aren't always cheap, right? Somebody's got to feed Jensen, but you can get a lot of return for your dollar if you run them correctly. And it's almost just like running a real company, right? Where if you're bad at management and steering and tracking inputs and outputs and, keeping everybody marching to the right tune, you're going to be inefficient there as well. The same thing happens when using these AI coding agents. So it's not a replacement for a senior engineer. And it's not the sort of thing that turns a junior into a senior, but the right kind of senior engineers and architects, it is like a 5x, a 10x, output if you can harness it and drive it and steer it correctly. And it's getting more and more applicable to more and more verticals, like not just every year, every 6 months. Right?
Oh yeah. Heck, every week. I mean, and it's not limited to code. Like I don't want anyone thinking that this is all code. No, like this thing can help you organize yourself and your thought processes and the projects you're working on. And just take your whole body of work and help you get through it faster. The whole agentic workflow is like having a boatload of little assistants that are keeping track of things that you may even forget, right? It's all a matter of figuring out how to spin that team up and keep them on task.
And I'd have to add to that and say the quality of the output is directly proportional to the quality of the expectations set with these agents. It's not simply just ask a question. It's ask, direct, guide, set expectations, set up expected output and outcomes. So that way it can think, it takes your request and can think about it versus immediately trying to respond for that first answer.
Yeah. And that's why we're saying that you have to keep it aligned, and that it tends to help people who've done this a lot, right? Who understand and are technically apt. They know what questions to ask, where the bounds are, when an answer is bull, right? And be able to keep things straight. That's why it doesn't make a junior into a senior guy, because the junior doesn't have that experience yet. He's not able to validate that he's asking the questions correctly and getting the correct results back. Anyone who kind of takes the answers whole hog and just runs with them is going to find themselves hitting some serious walls. But for people that have been doing this a long time, getting that help and keeping it straight can really, really be that huge multiplier.
It was something that was kind of bothering me. Well, not really bothering me, but I was thinking on it at GTC is, when you think about networking, just that as a focus for me, right? I mean, I think about software-defined networking, right? It's a programmed approach to kind of building your infrastructure. And that I see that changing, right? It's going to be more of a self-optimizing, autonomous, approach long-term as these things continue to mature. Where, I think that the whole methodology is going to be a little different. And you see it in practice. I mean, we saw it with some of the factories discussions and kind of saw how, hey, they were building a digital twin, and the digital twin was injecting live data, and it was constantly updating the model so that it could go and make itself more efficient, find areas where there were weaknesses. And I see that happening on the network side as well. So it's definitely exciting to see where it's going. But I think that, in those worlds, obviously, you still need those top-end experts to really help keep it in check, right? Keep it in terms of, yes, this is a good idea. No, this isn't a good idea. There's still things that have to kind of tune and twist through that change. But that was the biggest kind of takeaway I had in terms of all the interaction and talks that I had over there.
Experts like perhaps WorldTech IT. Well, there we go, guys. We're going to wrap this up here so we can get a couple of these guys out of here. I have time for one very quick lightning round, as we always like to do. So I would like to hear the wildest thing that you saw on the GTC trade show floor. Last year, we saw a grape being operated on, like sliced with a scalpel. You got to beat the grape with the scalpel. So what did you guys think? What was the craziest thing you saw?
The craziest thing I saw was the quantum computers that they had on the floor, and just the optics and like the hardware and everything that went into building those things. I don't think you could have done that even 3 or 4 years ago, let alone five to six.
I'm going to go the entertainment round. I love the robot DJ.
All right, there you go.
I got to see a skateboarder jump over a robot, and the robot did a barrel roll. So that was pretty neat to see.
Yeah, I mean, all the robots were really crazy to see. There were ones the size, that come up to your knee, all the way to full human sized, and everything in between. Yeah. Moving in all sorts of strange ways. There was even Disney Olaf, a little robot that they showed off, walked on stage, talked to Jensen, walked off. Interesting that they can make something that shape, do what it needs to do and kind of be semi-autonomous. It was pretty neat.
I think the robots have it, guys. Well, that'll be it for our WorldTech IT GTC Recap podcast. Join us next month for another exciting pod, and we'll see you guys next time. Thanks, everybody.
Sounds good.